So we're going to look at two examples here that require chain rule. Chain rule needs to be applied if I have a composite function, so a function within a function. So like in this first example, I have this inner function inside the parentheses, and then the outer function would be 3 times this thing being cubed. In class, we talked about writing the inner function as g, the outer function as f. You're welcome to do that. Over time, you'll probably reach a point where you don't need to do that anymore. So, okay, so I can see here that I do need to apply the power rule because I have something being raised to the power of 3. So dy dx will need to be, if I bring the 3 down and multiply 3 times 3, that gives me 9. What's in the parentheses, the inner function, is going to stay exactly the same. So that's still 2x squared minus 5, and then applying power rule, I subtract 1 from the exponent, so this would be squared. The thing that students are very likely to forget about in chain rule is that I then have to multiply by the derivative of the inner function, so by the derivative of what's inside of the parentheses. The derivative of 2x squared would be 4x. The derivative of negative 5 is 0. So I could leave my answer like this unless I was asked to like simplify it, or on a multiple choice question you would likely have to combine the things that can be combined. So in this case I can multiply 9 and 4x, which would give me 36x times 2x squared minus 5 squared. Okay, let's look at the other one, which also involves chain rule. It's just slightly trickier because we have a radical. So I'm going to start by rewriting, by rewriting y from radical form into exponential form. So since this is a square root, I can rewrite this binomial as being raised to an exponent of 1/2. Now I'm ready to take the derivative. So dy dx, again, I'm just applying power rule, but then I'll have to remember to multiply by the derivative of the inner function. So I'm bringing down that exponent, so I have 1/2. What's in parentheses stays the same, so x cubed plus 4x. I'm subtracting 1 from the exponent. So 1/2 minus 1 becomes negative 1/2, and then I have to multiply by the derivative of the inner function. So the derivative of x cubed is 3x squared. The derivative of 4x is 4. Okay, if I were asked to write my answer in radical form, I have to do a little bit more work here. So I'm going to take this negative exponent, so this entire piece, and move it into the denominator so that it can then have a positive exponent. So remaining in the numerator would be 3x squared plus 4. From this 1/2, the 1 is in the numerator, so I don't need to write it. And the 2 is in the denominator. And then I have x cubed plus 4x, now to the positive 1/2. And then the last thing would be to change from exponential form, where I have this fractional exponent, back into radical form. So my final answer in radical form would be 3x squared plus 4 over 2 times the square root of x cubed plus 4x.